it's time to work on the analysis of variance in Excel, which is the direct calculation. Remember, this is our data set that we're using. Our Excel calculations are going to be based first on an example where the null is true. And the null is that, as you can see, I've got 1, 2, 3, 4, 5 groups here. There are 10 individual samples or observations in each group. All right, so there are 5 group means down here at the bottom. The null is that these 5 means are all the same, right? That they're drawn from the same parent distribution. So remember, what we're going to do for the analysis of variance is over here in this box is we're going to compare the total table variance as it's estimated, right? So when I say the table variance is estimated, we're not really estimating this table. We're using this table to estimate the parent distribution from which it was drawn. So it was either drawn from 5 different or several different parent distributions, or it was drawn from one. So what we do is we make these estimates based on the assumption that the null is true. That would be the assumption that all 5 of these groups were taken from the same parent. And if that's true, then the 2 different estimates that we make will have about the same value, the same estimation. The first estimate we're going to do is from the variance of means, and I put that formula here. You can see that at the top of the screen. That is var.s, which is variance estimated from a sample, which uses n minus 1 in the denominator, and it is actually the measure of the variance of means, these 5 means. So we know that because the variance of means is proportional to the variance of the parent by the size of the samples, which is n, right? That we know that if we have the variance of means, we can simply multiply it times 10 to get the parent distribution variance. And so that's what we do here, and that was pretty straightforward. And then that was actually the hardest calculation here. And then the other one we're going to do is the mean of the variances, which is by, if I look at those formulas, each one of those is simply the variance of each of the columns. And so we know that the mean of the variances is the best estimate of the parent distribution variance, so we do that. Alternatively, you could have just selected all the cells in the whole thing and calculated the variance from that. That should be about the same. But now we're going to make a ratio of this number over this number, the variance of means estimate, and over the means of the variance estimate. And then that makes our thing called an F ratio. That's simply those 2 numbers. Now remember, the F ratio should be close to 1 if the null is true, and it should be larger than 1 if the null is not true. So let's take a look at, we have one last thing to do, which is degrees of freedom, which is required in the F test. And that is, I can just give you these numbers really. The numerator, which is the variance of means on the top, right? That is a degree of freedom of the number of groups minus 1. Okay, so that's 4. And the degrees of freedom of the denominator is basically n minus 1 in each group, because we did a variance down here where you did var.s, so we used n minus 1. And then we did that with 5 different groups. So n minus 1 is 9 times 5 is 45. That goes here. And then the p-value at the end. To find the p-value, we need to put in a number. I'm just going to go ahead and delete what I have in there so you can show how I find it. I go into that cell. I push the f of x button to look for a formula. And then I'm going to do fdist. There it is. I type in f, and up comes fdist. So fdist asks me for a few different things. It wants the number, that's the F ratio that I'm interested in, right? So I'm going to collect that number. All right, it wants to know the degrees of freedom for the top. That's the numerator. The degrees of freedom for the second number, and that's the denominator. And the cumulative is a logical function. It means we're just going to write false in here. I can show you what that means in class later. That's our result. Okay, and our result says that for this particular data set, close this window, the p-value is 0.7, so it's much greater than 0.5, so we can fail to reject the null, right? I don't think you'll be able to see that in my video, but that's okay. There we go. You can see it when I put it in here. Fail to reject null. Great. It's really that simple. Um, Remember, the equation here at the top that we're using is the same in every cell in the whole table. That makes the null true, right? Which is every table has this equation written in it. And this equation says that if you round, um, basically that you're taken from a mean of 60 and a standard deviation of 10, a normal distribution. So that's what you're being drawing for each of these different cells. So in the next example, what we're going to do is shift the means so the null is no longer true, such that the group A has a different mean than group B has a different mean than group C. All right, thanks for listening.